So this one is concurrent lines, perpendicular bisectors, and medians of triangles. So there's a lot of vocabulary today. In fact, that's probably the gist of this lesson is vocabulary.
Oh, Maddie, you're slow.
When three or more lines intersect at one point, they are concurrent. And the point at which they intersect is called the point of concurrency. And so that is basically what this whole lesson is about. Lines being concurrent and the points of concurrency. There's two different points of concurrency we're going to talk about. The first one starts off by talking about perpendicular bisectors. And that's going to take us to the circumcenter. So perpendicular bisectors, we've already talked about those in 5.1 and before. The perpendicular bisectors of the sides of a triangle are concurrent at a point equidistant from the vertices. There's a lot in that sentence, so I'm going to go back over it one little piece at a time and kind of let this sink in. And we're going to use the picture to help. So the perpendicular bisector of the sides of a triangle. Okay, so perpendicular bisector of the sides of a triangle. So I'm just going to look at one side of the triangle to start off. So the side A to B is bisected. Whoa. So bisect means to cut in half. We can see the two lines, so it's cut in half. So that's the side that's bisected by this line L.
I'm leaving the second period early. Oh, it's fine.
That's just recording. And it's a perpendicular bisector. So you can see in that bisecting line meets the side and forms 90 degrees, because that's what the little box means. So the side is bisected. And notice that side, this line, it doesn't match up with angle C. That's on purpose. It's not like just off because the way it was printed. The perpendicular bisector, the focus of this one is the 90 degrees on the side. And then it goes wherever it goes. It doesn't have a specific destination in mind. It's just going 90 degrees out wherever it goes. So the perpendicular bisectors of the sides of a triangle, because there's three of them, right? Because there's three sides, so there's three of those bisectors. They are concurrent. We just talked about what that means. It means they meet at a point. So they're going to be concurrent at a point. So here it's going to be this point O. And that point is equidistant from the vertices. Equidistant. Might already figure out that means equal distance, right? From the vertices. Vertices is just plural for vertex. You have one vertex, you have three vertices. So after you could draw three perpendicular bisectors, wherever they meet, that point of concurrency is going to measure equally distance from each angle, each vertice. So I could draw that in here. So this length is going to be the same as, whoa, and not a straight line. This length, which is going to be the same as this length. So those green lines are all the same length, and they go to the angles. Okay, so that's saying that this should be segment. Segment AO is congruent to segment BO, is congruent to segment CO. So from the angle to the point where those three perpendicular bisectors meet are all the same length. And so this is properties of perpendicular bisectors. And that point of concurrency is called the circumcenter. So the point of concurrency from the point of concurrency of the perpendicular bisectors is the circumcenter. So let's talk about what that word means. Circumcenter. Center of circumference. Circumference is what goes around a circle. Remember that from when you first learned super basic geometry? Circumference of a circle is the perimeter of a circle. So here's the second note. The perpendicular bisectors of a triangle will help you locate the circumcenter so that you can circumscribe a circle about a triangle. Again, that sounds kind of silly. So when you circumscribe something, everyone probably has seen the picture, like the Da Vinci picture. It's like the man with his arms and legs out and it has a circle around it, right? You know what I'm talking about?
Yes.
Oh, we'll get back to that later. So that circle is circumscribed around whatever image. So it's kind of helps, I think. Oh, I need this in red. So if I take the edges or the angles of the triangle and I put them on the edge of a circle, I circumscribe the triangle. That's circumscribed, and that point that is where all of the perpendicular bisectors meet, that is the circumcenter. It's the center of the circumference. Kind of makes a little bit of sense. You're not going to have to do the whole circle thing. I'm just doing that to explain more what that point is. That point is in the middle of the circle. It may look a little off. My circle's a little bit oval shaped, but for the most part, it's the center of the circle if you were to put the edges of the triangle on a circle, which is why it's called circumcenter, center of circumference. And it's made by the perpendicular bisectors. So that's the first concept. So now we're going to do a little bit of practice with it. For the triangle, give the coordinates of the point of concurrency of the perpendicular bisectors of the sides. That parentheses A should not be there. So for the triangle, give the coordinates of the point of concurrency of the bisectors of the sides, of the perpendicular bisectors of the sides. So what is that point called again? The circumcenter. Yeah, what we just went over. It's the point of concurrency of the perpendicular bisectors is called the circumcenter. And it's going to be an XY coordinate. So to find it, what you will do is, well, the shape's already drawn here, so we need to bisect each side. So here I'm looking at the left side, the vertical part. I see it's 4 units long. So if I want to put a bisector, I would go to the middle, the midpoint of that line, and draw a line. And then I have to do, it's perpendicular, it meets at 90 degrees, and then I need to do it again for the next side. So the bottom, vertical and horizontal lines are very easy, right? Because this is another 4 units, so I go halfway, the midpoint, and then I'm going to have the line going 90 degrees from that line, so straight up. And then the third side, the middle of the third side is here, and then it's going to go straight 90 degrees from that. And then the point where those 3 lines meet is the circumcenter, which in this case is right here. It's not always going to be on the triangle. Like in the one above, it wasn't on the triangle. But it will always be equidistant from the angle, from all 3 angles. And this is at the point 2, 2. So if I were to draw, if I were to circumscribe this triangle, let's see if I can get it, where all of the angles are on the edge of the circle, if I can do that, then the red dot is in the middle. And it's the equidistant from the center of the circle to all of the sides. Okay? So one more set of practice for circumcenter. We're not going to do the last one, by the way. You're welcome to do it if you like, but we're not going to go over that one. All right, so in the diagram, the perpendicular bisectors are shown with dashed segments. I know you guys already know I like to use color. Makes it easier to say what I'm talking about. So the dashed lines I'm doing with my green highlighter, those are the perpendicular bisectors of triangle ABC. They meet at point G. So point G is the circumcenter. All right, so if that's the circumcenter, we know the circumcenter is equal distance to all of the angles. And then we're just going to fill in what it's asking about. So AG, so what is the segment AG from A to G? So here. What is the length of this? Well, that is the distance from an angle A to the circumcenter G. So that would be the same as the distance from G to angle B, or from G to angle C. And G to angle C has a number. It's 25. So that means G to A is also 25. And it didn't ask, but G to B is going to be 25. Because the circumcenter is the same distance to all of the angles. Next it says BD. So B to D, right here. It's a side. And perpendicular bisectors do what to the side of a triangle? Bisect it? Yes. Yes, they do. And what does bisect mean? It means to cut it in half. So that means that AD is the same as BD. So if AD is 20, then BD is also 20. And number 13 says CF. So where's CF? All right, C, that's the bottom. So C to F. Again, we're on the side, that's the bottom side of the triangle. It's been cut in half. If this side is 24, then this side must also be 24. Number 14 is AB. So side AB, the entire side, left side of the triangle. Well, if both halves are 20, then 20 plus 20 is 40. Okay, number 15. CE. Here's C, here's E. So I'm on the right side of the triangle, but just half of it, I know the other half is 15. So this side is also 15. The next one asks for AC. AC is the entire length of the bottom of the triangle. So it's 24 plus 24, so it's 48. And then the last one, number 17, is asking about an angle. It says the measure of angle ADG. A to D to G. So it's this angle right here. What is that angle measure? What angle does this green line meet the side of the triangle? At what angle does the perpendicular bisector meet the side of the triangle? 90. Yeah, is that what you said? Oh, no, the angle. Yeah, DG meet AB. Yeah, 90 degrees, because perpendicular means it meets at 90 degrees. So this is 90 degrees. Or you can put a little box there, because that's what perpendicular means, 90 degrees. Like the X and the Y axes are perpendicular. They meet at 90 degrees. So that measure, this angle is 90 degrees. And the same over here, for that green line, that's also 90 degrees. All perpendicular bisectors. Okay, so that's the first part of the notes. It's talking about circumcenter, the center of the circumference, and perpendicular bisectors are how you find the circumcenter. The next part is very similar, and this is where it might get a little confusing. Medians. So a median of a triangle is a segment whose endpoints of a vertex and the midpoint, the endpoints are a vertex and the midpoint of the opposite side. So when you draw a median on a triangle, you start at the vertex or at an angle, and you draw the line to the midpoint of the opposite side. Okay? So if you have a triangle, any triangle, you start drawing at an angle, the vertex, and you take it to the midpoint of the other side. So the other side has to be exactly in the middle. That's a median. The difference is the angle of where it hits the midpoint it could be anything. And you can see that in the picture. So here we have the side of a triangle. It's not 90 degrees. It's not perpendicular. It goes at a slant because it's going to the angle across from it. A median connects the angle and the midpoint of a side. So whenever you have the point of concurrency of medians, that is called a centroid when you're dealing with medians. So medians of a triangle are concurrent at a point that is 2/3 the distance from the vertex to the midpoint of the opposite side. Now, the most basic way to teach this is with fractions, but we all know how much you love fractions. I have another way of teaching this that I feel is the simplest, where I'm not even going to go through this part right here, where it talks about 2/3, and then you have to figure out, are you going to do 2/3 or 3/2, depending on what you're given and what you're looking for. The easiest way to do all of these problems, in my opinion, is if you have a median of a triangle, since 2/3, the point is 2/3 from the vertex to the midpoint. So if the denominator is 3, what is that telling you of any fraction? What does the denominator of a fraction tell you? Oh, yeah, but it tells you that's how many pieces are in total, right? So if it's 6 out of 5, 6 out of 5, 5 out of 6, that means there's 6 pieces, right, in total, and we're talking about 5 of them. So 2/3 means there's 3 pieces in total. So if we take the median and we split it into 3 pieces, and we make them equal. Oh, I messed that up with my colors. Boop, boop. All right, there we go. So we have 3 pieces. The median is split into 3 pieces, and they're all equal. So we divide evenly by 3. So there are little red lines showing that they're all equal, that they all have 1 dash on them. Then once I break it down to this, I find out what one of those are. It doesn't matter if I'm asking for 2 of them, for 1 of them, for 3 of them, because you just add them up, right? So just always break it down into finding out what one of the units is. And the centroid is 2/3 from the angle to the side. So it would be right here, closer to the flat part. That's where the centroid is. It's also the center of mass. It's the balance point. So if you're trying to balance something, balance a triangle, you balance it on its centroid. It's the balance point. So here it's this one. All right, so if I'm splitting this, again, looking from D to J before I even get into the examples. It's a median. The top part closer to the angle is split into 2 pieces, and then the centroid is where I split it into the other third. So I have 3 pieces now. Let's look at an example. If DC is 16, what is DJ? All right, so DC is here. It's telling me that is 16. So if that section is 16, what is each piece? How many pieces are in the highlighted section? 2, right? So if the total is 16, what is each piece? 8. I'm splitting it up, right? So then that means that this part is 8 and this part is 8. What is the third part? It's also 8, right? Because the way I marked the triangle I drew over here on the side is I split the median into 3 equal pieces. So 8, 8, and that means this side is also 8. Because from D to C is 16. And it says, so then what is DJ? Well, DJ is the entire median. So that would be 8 times all 3 pieces, which is 24. Does that make sense? You say no or yep? No? Okay. Let's do it again then. So DC in the picture is here. It's saying that is 16 units long. And it's asking me what the whole measure of the median is then. So before I can say what the entire length of the median is, I have to figure out what the other section is. I know a median is split into 3 pieces, 3 equal pieces. Because that's what the theorem I just went over was. And so I did a representation over here where I took a median and I split it into 3 equal pieces. And, let's see, right here is where the centroid is. That's the centroid. So there's 2 sections of the median closer to the angle. There's 1 section of the median closer to the side. So there's 2 sections up here and there's 1 section down here. So over here in the triangle from D to C, the highlighted yellow part, there's 2 sections there. So I'm just going to mark it as 2 sections, 1, 2. So this whole median now is in 3 pieces, 1, 2, 3. And this tells me that DC is 16. So from the angle to the centroid is 16 units. So if I split that into 2 equal pieces, then they're 8 and 8. This is 8 and this is 8. But I know the median in total is 3 equal pieces. So that one is also 8. And it's asking me for DJ. DJ is the entire median. So that's 8 times 3. So it's 24. So you want to every time break it down to find out what one of those pieces is, and then you'll either be, your answer will be one of them, it'll be 2 of them, or it'll be all 3 of them, depending on what part of the median the question is asking for. All right, so I'm going to look at the next one. If FH is 27, so this time FH is the entire median. And it's asking me what is FC, which is the longer piece. So before, instead of trying to figure out what 2/3 of the median is, what I'm going to do is I'm going to split up the entire median from F to H, because you always want to go from the angle to the side. So F to H, like that, 3 pieces. The whole thing is 27, so it tells me that this is 27. If I want to split it into 3 pieces, then I'm going to divide by 3, so each section is 9. And it's asking me for FC. So F to C is 2 of those pieces. So it would be 2 of them. It would be 9 times 2, which is 18. Make sense? Maybe? And then I'm not going to do the one with the algebra. We're not trying to do that. Just trying to keep it basic for right now. It could have asked me, what is CH? If that same one said, what is CH? CH is from the centroid to H, to the side, so that would just be 9. So if it's asking for the part closer to the side, that's one of the sections, and one of the sections is just 9. The part closer to the angle is 2 of the sections. The entire thing is 3 sections. So then the last part for today, this actually doesn't have a question, so I'm going to have to write it. A sculptor is shaping a triangular piece of iron that will balance on a point of a cone. The coordinates of the vertices are 3, 0, 6, 4, and 0, 8. So that is the triangle that's going to balance on the tip of a cone, right? 1, 2, 3, so this is a sculpture. 3, 0, 6, 1, 2, 3, 4, and then 0, 8 is at the top. So my question is going to be, at what point on the triangle should the sculptor balance the place the triangle? I don't know, something like that. That's probably not worded right. So basically what I'm asking is, where's the balance point of the triangle, of that flat piece of iron, right? So it's saying, where is the centroid? That's another way of saying it. Where is the centroid? So to find the centroid, the balance point, first I have to draw my triangle. I go from the angle to the midpoint of the side across from it. So always start at the angle. It's easier to start at the angle and go towards the side across from it. There's my triangle. So now I'm going to start at the top angle. From that angle, I'm just drawing to the midpoint of the other side. And then from the next angle to the midpoint of the side that's across from it. And again, from the third angle to the midpoint of the side that's across from it. And where those 3 points intersect is the centroid. Right here. So that's the center of balance. 1, 2, 3, 1, 2, 3, 4. So it's at the point 3, 4.